So let's talk about section 5.5, exponential functions and investing. So everything that we've been working up to now, dealing with exponential functions, actually does have a practicality, and the practicality of it is with investments. Okay, so we're going to start talking about finding the future value of investings, talking about things that are being compounded so many times per year. We're also going to look at what if it's compounded continuously. And then we're also going to look at finding the present value of an investment. And we're going to look at using the calculator to help us out. Okay. So with that being said, all of these are going to be word problems. So when you start to look at the rest of these sections, they're going to start showing a lot of word problems with your just homework. So be aware that it is very wordy and that you're going to need to kind of break down and look for keywords as we work our way through them. So with our first thing, as we kind of jump in, to numerically and graphically, we're going to look at how $1,000 is going to grow at 6%. Now we're going to do it compounded annually, and we're going to do this in kind of a table format. Now we've looked at this a little bit already. So remind yourself that if you are putting something exponentially, it's going to literally be 1 plus our rate. And so in our case here, we're doing 6% rate. Okay. So it's going to be 1.06, but then we're going to raise it to the power of what type of years, like how many years is it? So after 1 year, we're going to have this kind of just base idea of what we're looking at. Okay. Now, the second part that a lot of people, you may have misread this, is that this is literally $1,000 that we're growing. So remember that when we're doing our future values, that the formula that we're looking at here, 1 plus 6% to the power of t, this is for just any general starting investment, but we do have to add in what is our initial investment. So remind yourself what we put right here. This is going to be how much money I start with. Okay. So I'm going to kind of make a note down here. So realistically, what we're going to put in our calculator is, and again, this is what we were looking at earlier. Okay. To the power of time. So, oh, that P looks really awful. I'm sorry. So let me fix my P value there. Okay, this is basically the formula that we were looking at in previous sections. So it's literally, what am I starting with? Okay, so we're starting with $1,000. Again, $1,000. And then we're growing it at a rate of 6% to the power of whatever our time is. Okay, so from here, we're going to look at it and we're going to do different time values itself. Okay. So I'm going to let the calculator, and then we're going to look at the graph, and then we're going to, graph the function and see as it continues as a function itself. So let's take a peek at our table there. So with our table, the first thing I'm going to do is I'm going to go into y equals, clear out anything I have in here, and I'm going to actually plug this into the table. Okay, so I have 1,000 parentheses 1.06. Now I went ahead and added these together and then raising it to the power of t. Now the calculator is not going to put in t, it's going to put in x, because again, we're using y and x, just like I'm not using s equals. Like the calculator only has like 2 variables that we're using when graphing algebraically. Now I know there says other variables, but again, we're only using the x part of it because that's the type of graph we're looking at. And then I'm going to go into the table. Now, be aware that the table itself is set up pretty much to automatically populate. If you have messed with the table quite a bit, so go to second window. I'm going to start my table at 0 years here. I do want my table start to basically be 1. Table start be at 0, but my table changing, the starting of the change is to be 1, which means if I start at 0, the next number will be 1, and the next number after that will be 2, 3, 4, so on. So this is kind of where, and I had these both set to auto. If you put it to ask, you have to put in stuff in, and it doesn't make it as easy if you don't know what you're looking for. So until you're really comfortable with this, I just say go ahead and put it auto and automatically populate it. And then second graph, and again, so we can see there that if I put $1,000 away in the bank account right now, I've just put it in the account, it hasn't earned any money, so we have 1,000. After 1 year, if I've got 6% interest, I'm going to have $60 added into that 1,000. So I have $1,060. After 2 years, I'm going to have $1,123.60. Okay. And we can see as it grows there. So it does look super, really cool and awesome. Okay. So as we continue to go now, if I were to look at this and just look at each one of those as individual dots, this is what it will look like. But guys, do remember that going from 0 to 1 year, 1 year to 2 years, 2 to 3, there is time in between here that the money is still growing. Now, normally I wouldn't stop, but if it was looking continuous, like the function that we created, if we were to look at that, that would show a straight line. And again, I've already put it in the calculator, okay? But be aware that since I plugged it in the calculator here and I was looking at second graph, that was the table. When I hit graph, I don't see anything. Why don't I see anything? Well, that's because my window is set differently. So currently my window says my X values, which is my time, years, is set for negative. Well, we don't have negative time, so let me just go ahead and change that to 0. Okay. Also, my Y values is set to max out at $10. Well, I start off by putting $1,000 in the bank account, right? So since I'm starting off at putting $1,000 in the bank account, let's put in like 800 here. Okay, that way I see a little bit below it. But my max, I've got to like go above $1,000. Okay, so let's just type in, say, 2,000. Now, if you were looking really closely at that table, you notice that after 10 years, 2,000 looks like it's pretty okay. Okay, but if I continuously go, I might need bigger than 2,000. So, and we can see right there, there's that graph. Again, all of these points are listed there. So if I were to look at those individual values at time 0, at time 1, at time 2, so 1 year, 2 year, 3 year, 4 year, all those are there. Okay. Now you'll notice there's no line written down here, and that's just because we have it literally, it's to draw right there. If you want to see that actual line, I recommend maybe going a little bit below it so you can actually see a little bit. Oh, sorry, I put the wrong thing. Put that at 0. Let's put this at, you'd have to go a little bit below this. So I would have to say like -10. And then you can start to see that actual line itself there. Okay. But just be aware that we can kind of jump it up to 800. Now, the other thing that you'll notice is that, so this is starting now at 800, which is why you don't see the line there. This is a very thick black line. And that's because the scale right now is currently set for every one, there's a tick mark. So that's going to be 801, 802, 803, 804, 805, 806, 807, and so forth, which is a lot. So if you'll notice when we look at what they've drawn here, every tick mark actually represents 100. So if I were to change Y scale to 100, I notice that now all those tick marks are a little bit different. They look spread out and looks more like the graph that they kind of showed me here for all the individual points. Okay. Again, this is what it actually looks like. And we can see that if I put that $1,000 in the bank account and don't touch it, whatever you do, don't touch it. But if you just put it in the bank account and don't touch it, we do have this kind of nice, beautiful, growth. Okay. Now that formula that we are actually creating, which we kind of started to explore in the last section, is pretty much what we call the future value of an investment with an annual compounding. Okay. Now I'm going to use S to represent my future value there. P is going to represent my present value. R is going to be my rate. And again, this is normally given as a percentage in the problem, and T is time. Okay, now this is if you're looking at an annual compounding, meaning you're going to be compounded once a year. Now, what happens if I'm not compounding once a year, but if I do them multiple times per year? That actually changes our formula just ever so slightly. So our new updated formula is, what if I need to compound multiple times a year? That's going to be S equals P parentheses 1 plus R over K to the power of KT. Okay, now as we're looking at this one here, again, I want to be very, very cautious. Okay, S is again the future value, P is going to be the present, R is still the rate. The only new thing I've added in here is K, and that's because previously K was 1 when I talked about annual. Annual would be 1 times a year. So do I really need this formula? Well, technically, these formulas are identical. The only difference here is this formula has K already in as 1. So look at this. If I take R and divide it by 1, I'm going to get R. If I take 1 times T, I'm going to get T. And that's literally what's happening with this formula. So do I really have to have this formula written down? That is up to you. It's your choice. But again, it is something that people talk about. But this is the formula I would strongly recommend. Make sure you have this one, and you can always turn to this formula. Okay. So let's actually use this formula and actually play with it a little bit. So we'll start with a very basic word problem. Now they will get a bit more complicated as we move into the other ones. So we're going to write an equation that gives the future value of $1,000 invested for T years at 8% compounded annually. Okay, so understand we're looking for the future value. So that right there told me, oh, right, future value means this formula that looks like this. Okay, now in our case here, again, I'm going to look for certain things to kind of help me out. The first thing I'm looking for is how much money am I putting away? Well, right there, they told me $1,000. I also noticed that I have 8%. Now, again, we don't really like that as 8%. We do like to change it to a decimal. Okay, so remind yourself, we're going from percents to decimals. Okay. Now, the other thing is K. K is what we kind of don't normally see. Now, in our case here, K, they said the word annually, which is 1, right? And so that means that basically when I plug in 1 into this formula, remember that this is kind of going to just disappear and this is going to disappear. Okay. Now write an equation that gives it for T years. So T is just going to stay as T. So as I plug everything into the formula, I am going to get S of T equals 1,000 parentheses 1 plus R to the power of T. Now, if we can, go ahead and simplify that out by combining those two terms together. So 1 plus 0.08 can be combined to give me a 1.08. And there we have our basic formula. Now, this is a pretty nice formula here, which will allow me to pretty much make any changes for whatever time I need to, okay? So I strongly recommend maybe make your formula for T years and then start plugging in what T is. Let's try that again. So we're going to write an equation. Again, write an equation, ladies and gentlemen, we are not solving for anything, okay? But we're going to do compounded daily. And again, it's a future value here. So as we look at this, again, this is the formula I said kind of lean towards. And again, for this one here, compounded daily, this is something other than annually, so that K is going to stay there. So how much money am I putting away? Well, I'm putting away $1,000, investing 1,000. We're doing 8%. Okay. And again, I really don't like to see 8%. We're going to change that to a decimal 0.08. T is still going to stay T years there. And K is daily. Now, daily, how many days are in a year? Well, 365 days. This should be, again, a word that we should already recognize as 365, okay? So as I plug into that formula, I'm going to have 1,000 parentheses 1 plus 0.08 divided by 365 to the power of 365t. Now, just so we have this down, when I look at this formula here, you'll notice I did not actually add 1 plus 0.08 divided by 365. And there's a reason for that, okay? Previously, I combined things together, and that was because we literally had like a really pretty decimal there. Ladies and gentlemen, when you look at this one, and I'm going to kind of pull this over here so you can really see this, 0.08 divided by 365, that is not a pretty decimal at all. Again, why do I know it's not a pretty decimal? Well, first of all, it says 2 point something, right? And then there's this E thing. So when I see things like this, just leave it in the crazy looking fraction. Just don't touch it. Just leave it be. Let it stay in the fraction, because I can still plug this formula in with that in a fraction. The calculator will know what to do. Okay, so we can leave it in this kind of crazy fraction format there with the 365. Okay, now one of the things I do need to make you aware of, especially for those of you guys who have a TI 83 versus an 84, or if you have an 84 and you don't have this option to where it looks like an actual exponent up here, we do need to be very, very cautious of our exponents with these ones for sure. Okay. And like I said, the calculator will know what to do. It will literally start putting the money where it needs to go. Okay. So what do these problems actually look like? So besides just writing equations, the question is going to ask us to actually write out some of these problems. So you're given $1,000 to invest for 2 years at 8%. What is the additional amount of interest earned in 30 years from compounded daily rather than annually? Okay. First of all, you're investing $1,000 for so many years at 8%. Okay. Now we want to know how much interest is actually earned 30 years. Okay. So, and we're going to do compounded daily rather than annually. Okay. So again, this means I am looking for what we talk about as a future value here. And since I'm looking for a future value, that's going to be that S equals P parentheses 1 plus R over K to the power of KT. Okay, so P, how much money am I putting away? Here's my P. What's my rate? Here it is. How much time? That's 30 years. And then K, I am actually comparing two different versions. Okay, so now remember, for daily, that's going to be 365. And for annually, that's 1 time a year. So for this one, we're going to use K being 365, and then we're going to use K being 1. These literally have almost the identical setup as we're looking at these. Okay. Okay. Now from here, since we're doing daily and annually, I've literally got two different formats of everything to put in there. So what I'm going to do is I'm going to erase just a little bit here. I'm going to make room for me doing these two different versions. Okay, and then we'll plug our stuff in the calculator. So we'll do daily on this side over here. So that means I'm going to have S equals 1,000 parentheses 1 plus 0.08 all over 365 to the power of 365 times 30. Okay, and then for the annually, that's going to be, again, very similar formula. S equals 1,000 parentheses 1 plus 0.08. Now I'm dividing by 1, so it's really just, you know, there, to the power of 1 times 30, which again, I know I'm multiplying by 1 or dividing by 1. So normally when we look at this one here, we're just going to go, because we don't normally write when we multiply by 1 or divide by 1. So okay, so now we got to plug all this in the calculator. So let me pull up my calculator. Bang, there's my calculator. Now, we're going to do this all in our home screen because, again, I don't really have a variable over here at all. So I'm going to type this in. Now, I am going to be very, very cautious. And so for those of you guys who do have a TI 83, or if you don't have a TI 84 that's been fully updated, hold off for a second and just kind of pay attention to what I'm entering in. And I'm going to make an extra thing for you guys because it's a little cautious here. So we have 1,000 times parentheses 1 plus, and again, if you have the ability to plug in as a fraction, totally take advantage of it here. Okay. Now, you'll notice I didn't actually put the 0 in front of the decimal. It doesn't really matter. The calculator knows. Okay, be sure to close your parentheses here and then raise it to the exponent of 365 times 30. Okay, now I am going to do this again, but this time remind yourself that we're literally going to change out that 365. Now, one of the tricks that I do find super helpful here is, guys, do remember that you can hit second enter to recall the last thing you entered, and then I'm just going to go in and I'm going to delete out this 365. Now, if you're really fast at typing, it probably took you about the same amount of time. So there is a slight difference. So if we have money that's earning compounded every single day, we're going to get more money because we're literally earning interest every day. Whereas annually means I'm only earning interest one time. Now, okay. So for those of you guys who have the TI-84, this is kind of what you wanted to remind yourself of, okay? I am going to make a slight change, so just be aware. Again, those of y'all that have a TI-83, okay, so your calculator is going to look like this, and the calculator screen is going to look a little bit different. So this is why, for those that have a TI-84 plus with that ability to make the nice pretty fractions and stuff, take advantage of it. For those that don't, okay, so for you guys, you're not going to have this ability to hit the pop-up screen and do this. Like, that's just not an option for you. So this is why I put my calculator in what we call classic mode here. What you're going to want to do is you're going to type it just like this. And then when you hit your exponent, this is where you have to be uber cautious. This is two things in my exponent. And so because of that, I need to make sure that I put parentheses around it. Okay, if you do that, you'll get the right answer. Please be aware that if you forget these parentheses, and this is why I'm saying if you forget the parentheses, for my people that have the TI-83s, it's very important here. Do y'all see how different those answers are? Only one of them is correct. Here, the calculator does not see that it's to 365 times 30. It just sees that it's to 365. And then this whole answer is times 30, which is very, very different, okay? So when you do this, again, those of y'all that have this ability to where it just does the little caret symbol and doesn't do the exponent, you need to make sure that there's parentheses around that exponent to make sure that you get it correct. Okay, everything else will be the same, and it's a little bit nicer when you have the just like one item in there being raised to the power of 1. So for you guys, this one again will just turn out perfectly fine, but it's the other one that's the issue with the 365 times 30. You have to put parentheses around. Okay. Okay. Now, the question in particular did ask me pretty much what additional amount of interest do I earn in 30 years if I put it in an account that does daily versus annually. And remind yourself that we're approximately earning $11,020.28 for daily and only $10,062.66. So I earn an additional $957.62 in interest if I choose the account that does daily. Okay, our next formula, and I warned you guys, there's going to be a ton of formulas here. So formula it up, guys. Okay, so this one, go ahead and make sure to write down. Very important to keep this one in mind as we are working on them, okay? And with this one, what I want to keep in mind as I'm working on this one is S equals P times E to the RT. Now, as you look at this one, P is still going to be, again, the amount that you invested. Again, it is a one-time amount. So again, this is a one-time thing. That'll make sense in the next section why I keep referring to it as one time. R, again, is still going to be my rate. Again, normally as a percentage, put it in decimal form. T is still going to be my time. And again, for this one, please make sure it's always in years when we talk about it. Now, E, you guys are going like, what the hell is E? She didn't define what E was. Again, we already know that S is future value, and that's something that we've talked about previously. Ooh, I just misspelled future. Good job, me. I I don't know, it just had a V in there for me. Yeah, we know that this is basically our future value, okay? And we know that P is that one-time investment and R is rate and T is time. E is the number E, okay? This is that 2.78182885, okay? That is where that is coming from. This is in the calculator, okay? So for this one here, this is in the calculator. Now, what do you know? How do you know when to use this? If it does not say the word compound continuously. Compound continuously is your keyword to use this formula. So compounded monthly, daily, quarterly, annually, some type of counting thing. That was the previous formula. This formula is only if they use the word continuously. So what is the future value of $3,500 invested for 10 years at 9% compounded continuously? There's my keyword right away. And so since I saw that, that lets me know, right? That's going to be my formula that looks like PERT. Okay. Remember the other formula is this one here. Okay. This is the other formula. This again is if it's some type of countable number. I can't count continuously. I mean, you can continue to count, but you're going to run out of breath really quick. Okay. So for this one here, this is again, this is when it says the word annually, daily, monthly, quarterly, semi-annually. This is what you would use again if you can count the word. So continuously, this one is for continuous. So again, that's where my two different formulas are. So what is the future value of 3,500, there's my P, for 10 years, well, there's T, and 9%, there's my R. So again, we have everything we need to plug in here. Okay. The second question is how much interest will have been earned on the investment, and we'll talk about that one after we get the future value, because we got to know the future value before we can go into it. Okay, so ladies and gentlemen, all we're doing is plugging into that formula. So again, remind yourself, this is going to be that S equals P times E to the RT. And we should have ended up with $8,608.61. Now, how did I plug that into the calculator? Okay, again, this is I'm still in the TI-83 mode. So for those of y'all that have a TI-83, again, you have to be uber cautious, and I am not stressing that enough. So I'm going to put my 3,500. Again, notice how I wrote this down, that both of these are in the exponent world. So second ln is going to give me my e to the power. You're going to put 0.09 times 10 and then close your parentheses. Okay, and that's where you're going to get your amount there. Okay, for those of y'all that have the pretty ability to make it look like it needs to, you guys are going to do that. Again, still same thing, hit 3,500 times second ln to get that e in there. It's going to show up looking like a beautiful exponent, and you don't have to be as cautious as my TI-83ers. Okay, so there we go. Again, here we have it. Now, that's how much money I should have in my bank account. Now, how much did I actually earn in interest? Well, let's think about it. Okay, this is how much money, and again, I'm going to kind of round it to 2 decimal places because we're talking about US money. So that's how much money if I round it to 2 decimal places. How much money did I put in the account in the first place? Well, I put in 3,500. So how much money did I actually earn? I earned $5,161. Okay. Everybody feeling pretty confident? Okay, so I'm gonna add another formula. You guys knew it was coming. No, it's coming. Okay, so let's talk about the present value. Like I said, just keep a sheet with all of these formulas out to the side because there's so many of them. So the lump sum that will give you the future value. So if I were to say, plug some money into an account right now, okay? If I put the money away right now and it earns money, what if I already know what I want the future value to be? So how much should I put in today to get the future value of what I want? This formula is called the present value. Now, this is not a new formula. We've actually seen this formula before, okay? This is just with a new kind of like update. So they use I and N, okay? I is just R over K. N is K times T. So let's look at the formula we looked at previously, which was S equals P parentheses 1 plus R over K to the power of KT. So instead of plugging R over K and KT, and again, we kind of want to start thinking in this format here, because especially in upcoming sections, they're going to switch to I and N. So I want you to kind of maybe rewrite this formula and say, okay, maybe I need to actually plug it in and change it to the following formula. So I'm going to erase R over K, and I'm going to erase K over K times T, and I'm going to replace those with now I, which is R over K, and N. And I'm going to take this formula and I'm going to solve it out for P, which, guys, this is multiplication. What's the opposite of multiplication? Division. So if I take S and divide it by 1 plus I to the power of N, I now have what is the present value given knowing the future value. Okay, so this one here is solved for future value. And this one here is solved for my present value. They are the exact same formula. It's just each one is solved for something slightly different. Now you do want to make sure that you write these down as well, because they're technically separate formulas that are inputted into these formulas. But again, in the next upcoming sections, we're going to be using I and N, and you really want to kind of know what I and N are. Now, this is also still the same formula as this one. This one here has that fraction. This here, remind yourself that if we look at exponents that are negative, exponents that are negative are pretty much the same as if it was in the bottom of a fraction. So this is just rewritten to where you wouldn't have to view it as a fraction. It is your choice. If you have a TI-83, I would maybe recommend, I would kind of recommend this one written down if you have a TI-83. But if you have an 84 with a really pretty fractions, this one's perfectly fine, or this one, you have that kind of choice. Okay, let's look at these problems and see how they are slightly different in the wording and what we need to look out for. So what lump sum must be invested at 10% compounded semi-annually for the investment to grow to $15,000 in 7 years? Okay, keyword there. We're growing to $15,000 in 7 years. Okay. Again, we have two formulas. The two formulas that we talk about, especially for compounded semi-annually, is these two here. Okay, these are same formula. This one here is solved out for future value. This one is here solved out for a present value. Now, the investment is going to grow to 15,000, meaning I already know what my future value will be. So if this is the future value, I have that. So we're going to use this formula. Okay. I already know the future value. I also know my time. I also know my R. I know my compounded semi-annually. This is my K. So the only thing, what lump sum must be invested right now? I'm looking for S. What is S? Okay, so I'm going to erase all my ink, and we're going to kind of lay everything out here. Okay, so the first thing I knew was my S value. Okay, so again, I already know my future value is 15,000. So this is my S value. I also know my T is 7 years. I know my rate is 10%, which again, we're going to switch into a decimal format. Oops, I saw my decimal there. Hang on. Okay, and there's one last thing I have to kind of keep in mind as I'm doing this problem. Okay, is K. And K is literally the one that's in words. Now, semi-annually, annually means once a year. So semi would mean twice a year. Okay, now in the formula, again, the formula itself that we're using here is the one that says P equals S over 1 plus I to the power of N. Now, there's an I and an N. There's no I or N written here. So this is where we have, okay, this is my formula, but I need to write a little extra bit in there. So I need to remind myself, what is I? I is R over K, and N is my K times T. So I'm going to take that 10% and divide it by 2, which is going to give me 0.05. And I'm going to take that 2 times 7, which is going to give me 14. Okay, and we already know what S is. So now we have everything we need so that I can plug into this formula. And everybody should have gotten $7,576.02. Okay, so we've added a lot of formulas, and I know you guys are like, oh my gosh, so many formulas. I do want to remind you that we also want to kind of look at a few things, but we also want to talk about modeling. So I've given you some data in the table, and it's going to give the annual return of an investment of $1 made on March 31st, 1990. And the values reflect reinvestment of all distributions and changes in the net assessment. Now we're going to exclude any sales charges. The reason why I say we're excluding sales charges, again, if you're investing money, most businesses are going to charge you a fee for like reinvesting or anything like that. So we're going to assume this is a perfect world and they're not charging us that, just so we get an idea of how this works. Now, what I want you to do is I want you to use an exponential function to model this data. So the first thing I'm going to need is my calculator. So we're going to open up my calculator. Okay, I'm going to move this over here. Okay, and we're going to stat, edit. Now I've got stuff already in here, so I'm going to clear out my list. Always clear it. And then I'm just going to type in 1, 3, 5, and 10. And then I'm going to come over here in my list 2 and type in my values here. Okay. Before I leave this section, I'm going to again remind myself, have I got everything in correctly? Just do a quick verification, looking here and looking at your screen, and make sure that you have everything in there. Okay, everything looks good. So I'm going to pull this over and again, look at the problem so we know what we're doing. Use an exponential function model. So I'm going to hit second mode, quit back out, go to the home screen, stat, arrow over to calculate, and I'm looking for an exponential regression. Now, again, exponential regression, exponential model, same idea here. Again, I'm not using the formulas because they asked me to use this model with a table. So if we're doing tables, we're using these regression things. Again, list 1, list 2. If you want to store it, you can. We're going to leave this blank and click calculate, and there we go. Now it says y equals a times b to the power of x. Here's my a, here's my b. Now they're going to tell you in every single problem what they want you to round to. So as you are looking at these, and again, I'll just go forth there, and we're going to look at that rounding. Now, if yours does not say what the R and the R squared is, remember I had to turn on my diagnostics to show that. This is not part of the answer. This is to tell me how well this correlates. R is our correlation coefficient. So I can see that it correlates pretty well, actually, almost like a 98% correlation there. So it's a pretty good correlation. Okay. And again, it's normally going to ask for a couple of decimals when you're rounding. So we have that 1.1609 raised to the times parentheses. And again, I have parentheses because that B value here is a little long. So 1.2004, close the parentheses and raise it to the power of X, or you can put it to the power of X and then close the parentheses, same difference. Okay. So now that we've created this beautiful model, I want us to use the model to find out what the fund amount would be on March 31st, 2001, if $10,000 was invested. Okay, and the fund continued to follow this model even beyond the year 2000. Okay, so with technology, we got our answer. So we know this is basically what our average annual return is. But remember, this was me returning $1. Okay, how does that actually change when I start going for maybe not $1, but $10,000? Okay, so use the model to find what the fund would amount to be on March 31st if $10,000 was invested at the original beginning. Okay, how in the world do I figure that out? Well, let's think about it. If this was originally $1, after 1 year, I got $1.23. So if I put in $10,000, this would actually correlate to that difference between there. Okay, so what we're going to do is literally, I'm going to start with the dates. Okay, so we started putting the money in the year 1990, and 11 years later is when I am going to look at how much money is in the account. Okay, now again, this here allowed us to create this model with our technology. So what I'm going to do is, again, this was for $1 being invested, but now I'm going to change it to $10,000. So I'm literally going to take this formula, plug in 11 in for my years, but I'm going to take all of this and just multiply by 10,000. And so if I do that, that means I should have about $86,572.62. Okay, now let's look at what question C was. So let me go back and look at question C real quick. Now, question C is it likely that this fund will continue to grow at this rate in 2002? Now, again, somebody has already done all the money and looked at this and said, oh, this was what it was in 1990, and this is basically kind of what it was. So if we were looking at this average annual rate return, will this keep going at this rate is what they're asking, okay? So if I put $10,000 away for 11 years, this is basically what I would expect in my account. However, is this likely to continue at this rate? Now, here's the deal. No, realistically, no. Why am I going to say no? Well, actually, most stocks and mutual funds actually decreased in value in 2002. And that was because terrorist attacks actually happened in 2001. So the stock market took a huge crash. And this is where, when you're looking at these stock markets and all things like that, we cannot project this to always continue to be perfect every single time. So in math class, when we look at this, we do look at it as hopefully kind of continuing on this trend. But in a realistic business sense, is it very realistic? No. But we have an understanding of the idea of what's actually happening with the money if we were to have a perfect world. Again, the world is not perfect, so we do know that that's sometimes where we have to kind of make adjustments for things. Okay, again, remind yourself you had a lot of formulas on this section. So again, if you are going to continue with these formulas, be sure to write them down. We'll have even more formulas for the next section.